All right, here we go for chapter 20.3, as promised, groundwater pollution. Probably one of the worst ones in a sense, as it's the hardest to deal with once it occurs. But let's go ahead and dive right in. Now, the chemicals that we wind up using in the biggies, if you will, agricultural, industry, transportation, and then just at homes, you and me, where we have spills or leaks, can make their way into the groundwater. The best thing we can do is protect our groundwater through pollution prevention. Once again, it's got to come down to prevention. We've got to keep it from getting in there, because then we have to deal with cleanup or wait a really long time for nature to run its course. And prevention is always the least expensive and the most effective strategy. Unfortunately, once people get used to a certain way of doing things, it's very difficult to get them to change. But it's what we have to do. Education along the way, and then we've got to have some laws in place as well. Groundwater can't cleanse itself very well. Streams, they clean themselves out really well. Lakes do a pretty good job. Groundwater, not so much. It's aquifers, right? It's just down at the bottom. Water's not flowing through here. It's seeping down slowly through the ground, and then a lot of the aquifers, it's just sitting down in little gaps between the rocks. Remember, we talk about porosity and permeability. So the aquifers are porous, they have lots of little holes, and then permeability is its ability to kind of float. So if we're pumping it up from here, it might move over here if it's permeable. But it's just the water down here in this empty spaces, if you will, down in the rock strata or in the ground. Now, aquifers provide drinking water for about half of the United States. Some of the most common pollutants that we find there, well, pesticides and fertilizers. Then we find gasoline and other organic solvents. Remember, organic solvents, typically this is coming from fossil fuels, whether it's benzene, toluene, a lot of these things which are fossil fuel derivatives are also making their way. Paint thinner, right? Gasoline or paint thinner, things that you and I might just use out and about, where these spill, get into the ground, and they leak down into the aquifer. And then not to mention fracking. Fracking is a huge issue when it comes to polluting our groundwater. Drilling down horizontally, shooting stuff in purposely to crack open and fracture the rock strata, and then we're kind of pulling this stuff back up. Well, in fracturing the rock strata, this is where our aquifers are. And we're going down through the aquifers in a lot of places, and it can leak into them. No matter how we look at it, slice it or dice it, fracking is an issue when it comes to our groundwater getting polluted. We've just had way too many instances of it that we can point source. We know it was coming from fracking. Anyway, it's a very slow chemical reaction as well. Now, up in the rivers and the streams, it's warmer, it's highly oxygenated, and the biodegrading bacteria breaking down the pollutants can happen fairly quickly. Well, down in the aquifers, it's a very slow flow, if there's hardly any flow at all. The contaminants don't get diluted. They're in there, and if they seep down, there's no more water coming and adding to it. So they're not getting diluted out. It's not flowing anywhere. They're remaining in it. There's not very much dissolved oxygen. Therefore, there's a lot fewer of the decomposing bacteria, and it tends to be colder temperatures. We're talking way deep down in the ground, right? I mean, it's above freezing, but a lot of times these water sources, here even in Florida, down in the deep water sources, it's still like 60, 65 degree water. And in a lot of places, it's just not much above freezing. It's 50 degrees or so. So the cold temperatures don't really lend to these processes being helped to break down the pollutants. Once again, if it's biodegradable. If it's not biodegradable, there's not a lot we can do. Now, if we look at this picture back here, it's kind of a diagram showing what's happening. So the blue lines are showing aquifers where the water's flowing between some of the bedrock. The red lines are showing sources of pollution. So sources of pollution can just come from the ground itself. Also when we're drilling and putting things in. Now it may be hard to see in some of these, but we put tanks underground. Boy, in my first house, I grew up as a kid, we had an oil furnace. Now when I was, I don't know, somewhere in probably like late elementary school, we shifted to a electric heating. But we had an oil furnace, and a truck would come up and they would pump oil down to a tank we had in the ground. And our furnace burned oil. And you know, if it got low, we'd have to come in. I remember we had to go in with a big dipstick and check where it was. But as a kid, but there was this big oil tank in the ground. Well, just a metal tank, right? And in time, metal tends to corrode and eventually it would leak out. Now with us, we stopped using it, but that tank's still in the ground. And I dare say we used all oil when we used it. I'm not sure, you know, my dad may have had it cleansed out, but it was just buried under the ground. Well, these tanks are all over the place and some are still in use. Well, when you start getting a leak in a tank, well, it drains out into the aquifers. We have gas tanks or oil tanks, all kinds of factories have things. We have pipelines running under the ground, and pipelines are joined at seams, right? Where some of these joints, we wind up getting leaks. All of these areas are where it can make its way into the water source. This is a diagram well worth kind of looking at and getting an idea of where some of these sources tend to come from. Now, this groundwater pollution is really kind of a hidden threat. We don't see it. Like if our lake is getting bad and it's all turned green and the fish are dying, we got red flags. We go, oh my goodness, look at that, it's horrible. We don't tend to see the groundwater, so we don't think about the groundwater. In China, it is estimated that 90% of the shallow groundwater is polluted, kind of that top layer of aquifer, if you will. Because a lot of times we get a shallow aquifer deep, and then we get the really deep aquifers, but those tend to be polluted with other things we're not talking about. We're just talking about, but they're most shallow, the one that most people are, a well, like you dig a 50-foot well, this stuff is contaminated, 90% of it. About 37% of it is so polluted that it can't even be treated for drinking water. Just horrible levels of pollution. So many people, and they have not had the same kind of laws and regulations to treat water and to keep the waste out as we have in the United States, and their water sources are in serious jeopardy. Liquid hazardous waste are injected into the ground and disposed in the United States. Okay, hazardous waste. We drill a deep well, we might encase it, and then we put it in it. Well, this can leak into the water sources, obviously, because it can leak out sideways. Especially if you get any kind of geological activity, it can crack and fracture these deep wells. But we inject these into the ground to try and keep it safe, but sometimes it leaks out. The EPA is trying to clean up these leaking underground storage tanks, but once again, there are millions of them out in the ground. Once again, the one in my old house, it's just buried and forgotten. The people that own the house now probably don't even know it's there. And this would be the case all over the place. We have these slowly degradable wastes, things like DDT, right? It doesn't go away. It gets sprayed out. They take decades to even thousands of years to clear. You get DDT down into a groundwater system, it's not going to break down. It stays in the system up here on the surface where it could break down for decades. It can be hundreds or, once again, even thousands of years in a groundwater where it's cool and not much oxygen, etc. Some things just don't break down very quickly, and it's even worse in our groundwater. Then of course we just have the non-biodegradable waste, and they remain there permanently. When you get things like lead and arsenic and mercury, these things don't go away. They're elements, right? They're well, arsenic isn't, but they're at their core of what they are. They don't degrade, they don't go away, but they can be hazardous to our health. Prevention, once again, is our most effective solution. We have to do something to keep our groundwater from getting polluted, because once it does get polluted, it is really difficult to deal with. The picture back here of the lady holding a water, that's just coming out of her tap. And this is from fracking. Out in Wyoming where they were doing fracking, by fracking and putting in, it got into the water supply that people were pulling their water out of. We've seen the pictures where people can light their water on fire from the natural gas, and sometimes it's as simple as this. It just gets overly polluted with sediments and other chemicals leaking into it. And once these aquifers get polluted, this groundwater gets polluted, especially to that level, there's not much we can do. We have to shut it down and go to a different source. Otherwise, you have to try and pump it all out, recycle it, clean it, and put it back in. Very expensive, if it can even be done, depending on the size of the aquifer. Now, our solutions, what do? Well, we need to find a solution for some of the toxic chemicals. Can we find a substitute, something other than chemicals that, once they make their way into the water, wind up killing you and me or causing cancer and all kinds of various problems? We should require leak detectors in all of our underground tanks, like our gasoline, right? You go to pump it at a station. Well, the big tankers come up and it's all stored underground. How do you know if there's a leak? All of our tanks need to have some kind of detection, so if it does occur, we can know about it and we can do something before it's a huge problem. We need to ban hazardous waste disposal in landfills. We've talked about the coal ash before, but there's a lot of other hazardous wastes that make their way into a landfill, and the landfill is not designed to handle hazardous waste. That needs to go somewhere else so it can be treated and or stored in an effective way that's not going to make it into the environment. And we want to store any of these harmful liquids in above ground tanks. We put it down in the ground, well, it definitely can leak and get into it. If it's above ground, we have a better idea of what's going on. We can let the water cycle run its course and we're left with sludge. It's still expensive, but it's a lot easier to deal with than once it makes it into our groundwater. Very, very difficult. That's all prevention. Cleanup, though, is very expensive. Well, we could pump all the water to the surface, clean it out, put it back in the aquifer. Once again, very difficult to do. You gotta have a tank big enough to do. You can't just clean it and put it back in. You're diluting it, but once again, this is a very expensive process. Depending on the size of the aquifer, it may not even be possible. We can inject microorganisms down into it to clean it up. If it's a biodegradable substance, even oil, there are bacteria that eat oil. So if it's gasoline or oil, there are some things we can put the microorganisms in that can break it down. Once again, it's expensive. We gotta get them, put them in, and then gotta give it time. You gotta stop using it till they can clean out the water. Or we can pump nanoparticles down into it and help pull them out. Of course, this is still under review of what to do and how to even do it. But it's an idea of using nanoparticles to be able to help break them down, pull them out, and then filter the nanoparticles out to clean it up. Once again, that's theoretical, but it is something that we are looking into. A case study. Let's talk about arsenic in our drinking water. Yay! No, it's not so yay, but it does occur. Now, arsenic winds up being in rocks. So when rocks break apart or get weathered, some arsenic can leak out. It's just a natural part of the rock cycle, if you will. But where you have arsenic-rich areas, like arsenic ore, not that we really think about it that way, but areas that are arsenic-rich, the more weathering that occurs, arsenic makes its way and it can contaminate the wells. Long-term exposure to arsenic causes skin, lung, and bladder cancer. Once again, you're inhaling it, you're getting it into your system, and it causes cancer of all of these areas. Levels tend to be especially high in Bangladesh, China, India, specifically the western state of West Bengal, and also in parts of northern Chile. But there are some areas in the US as well that are arsenic high, and we have to test the water and do some things to treatment. Now, there has been some development in looking at a treatment approach that literally you can drop rust in. You get a little, like iron filings, right? So you let them get a little rust, so it's ferrous oxide, FeO, and you drop that in, and the arsenic will tend to bond onto the iron. Then you can remove the iron just with hand magnets. So there are some fairly simple ways where people live where they know they're in kind of arsenic-rich areas they can do to treat their water, once again, It is a cost, it is an expense, but it is fairly low tech and something that is possible and capable of doing. So let's talk about purifying drinking water. Now, we have reservoirs and purification plants. If we're pulling the water up, we tend to pull it up, put it into a reservoir. Then you let it just set. That way the sediments will settle down, and then you can pull off the cleaner water. We'll just let gravity do its case. So you pull the water up, sits in a reservoir, runs through a purification plant, and here in the United States, we tend to add chlorine and fluoride. Chlorine kills all the wee beasties, fluoride for our nice teeth, helps us keep from getting cavities. We process our sewer water back into drinking water as well. We can purify the water back into drinking. And in California, a lot of places, they're doing more of that because they have such water shortages. It's better to retreat and recycle than try and find new water all the time. One of the things that you can do, we did this, we taught it to people in Nepal as well, as long as you have what we call potable, sort of clear water, if you expose it to sunlight, now we would tell people at least 4 hours, it needs to be in direct sunlight. This intense UV will kill all the infectious microbes. So if you have water that's at least reasonably filtered, but it's still going to have things like Giardia or other microbes in it, the UV light will kill it. It's a fairly cheap, easy way to treat drinking water. We lived in places where the water looked fine, smelled fine, but you would get horribly sick if you drank it. Simply putting it in a water bottle up on the roof for a few hours purified it. Also, there's been the invention of the life straw. There's a lot of these water filters, but the picture up here of the kids using the life straw to just drink out of that lake, which otherwise looks kind of nasty, but it's the same thing. It filters out all of the impurities, specifically when we're talking about things like microbes, bacterial, etc., that gets the water clean enough to drink. But this is literally life-saving technology in a lot of areas. Well, another case study. Talk about water, and here in the United States, lots of people drink water out of bottled water, right? Is bottled water actually a good option? Well, it can be useful, but it is expensive. The United States has been proven to have some of the world's cleanest drinking water, and I'm just talking straight out of the tap. But a lot of people still opt to buy bottled water that they tend to drink. You go to Publix or wherever and you buy a whole pack, and that's what you drink for your drinking water. Well, in the US alone, 67 million plastic water bottles get discarded daily. Daily, 67 million. Well, in a year, just the US, if you took those water bottles and lined them up end to end, it would circle the globe 280 times. So in 1 year, just the United States could put our water bottles end to end 280 times around. That's a problem, because this stuff isn't going anywhere. It lasts for hundreds, if not 1,000 years. We don't know what the life cycle of a plastic bottle is. We need to stop. We've got to do something to keep this down. And most of these plastic bottles, well, we're not lining the earth with them, but they are just making their way into landfills and in the lakes and in the rivers and in the streams and into the ocean. It's a huge issue and a problem. And in reality, most of that bottled water is just tap water, guys. Somebody in one place is pouring it out of their tap into a bottle, and you're buying it for 10 times, and probably more than that. The amount of water that it would take for you to drink in a year from your tap would cost you about 67 cents. That's like 3 liters a day. That's what the average person needs a day. 3 liters of water a day from your tap costs you less than $1. A single bottle of water tends to be around $1, at least 50 cents. 1 bottle versus your entire year's supply. If you're gonna bottle water, just get a container, fill it with water from your tap, and carry that with you. Don't buy plastic water bottles. Reuse one that you have. Buy an Nalgene and use it over and over and over. The water quality in the United States is pretty safe. Hey, if you're unsure, get your water tested. Just don't get it tested by somebody trying to sell you a water filter. The GRU here They'll test it. You can get your water tested. See if it's good and safe. You may be able to put a simple filter in it, but odds are you don't need it. We have some of the safest water in the world. Enjoy it. It's fairly cheap, clean, free. Well, maybe not free, but almost. When you're talking about 67 cents a year for all the water I need from a tap, yeah, let's take advantage of it. Now, we want to use laws to protect our drinking water quality. 1975, we passed the U.S. Safe Drinking Water Act. This set maximum contaminant levels for any pollutants. In other words, we said the water would not be safe to drink if there was this level of this pollutant, arsenic, E. coli, you name it. The health scientists recommend strengthening the law, but various industries have lobbied to weaken the law. So we have a law on the books, and it's there, but a lot of places say, oh no, it's too difficult, it costs us money to do this or to test the water. Well, you know what? We have a law on the books, let's keep it where it is. We have some of the best water in the world that is safe to drink. The Safe Water Drinking Act is one that we need to strengthen, if anything, not weaken. Now, less developed countries, they don't have a Safe Drinking Water Act. They don't have a safe drinking water law. And even if they do have something on the books, a lot of times they're simply not enforced. They don't have the means, if you will, to deal with it. Last case study for this section is lead in drinking water. A little while back, 2014, not all that long ago, we heard a lot about the residents of Flint, Michigan. They were exposed to dangerous levels of lead in their tap water. What happened was they used to take their water from Lake Huron. In order to save money, they switched and began pulling their water out of the Flint River instead of Lake Huron. Lake Huron had cleaner, better water source. When they took it from the Flint River, some of the other chemicals, components that were in it interacted with a lot of the lead pipes and caused a lot more of the lead in the lead pipes in more of the poorer home districts to leach into the water. A lot of these poorer homes, and I think it was, I want to say like 1978 was the line where we stopped putting lead in our pipe. Prior to 1978, lead was often used in the water piping and in fixtures and even in soldering, putting in the faucets. With lead was used in a lot of this. So a lot of the older homes all had this lead piping, and the water that they switched to was causing it to leach out. For a long time, the officials declined it. They said no, there wasn't any issue, but as it was looked into, the levels were just way above normal. And this can cause mental retardation. Lead poisoning causes issues with your cognitive abilities. And once again, it was largely affecting more of the poorer neighborhoods. So they would say, look, no, our water is fine, we have it tested. Yeah, well, the people that lived in the really nice neighborhoods were testing their water, and they weren't going and checking on the areas that really had the most problem. It was the older homes and more of the poorer neighborhoods that had the issues. But it was shown, it was proven that that was what was happening. Scientists were able to go in and determine exactly what the cause was and what was doing it. And because of the public outcry, not just in Flint, Michigan, but around the country, people said, no, something needs to be done. The water source was switched back to Lake Huron, and this effectively solved the problem. Of course, all these lead pipes need to be replaced and refixed. And if you're living in a house now that was built prior to 1978, it's something worth checking into, that your pipes might need to be replaced, because if they have lead in them, some lead leaches in no matter what, and lead's one of these things that builds up and it can be a problem. So the report indicated that the EPA actually failed to use its authority to protect the residents, but ultimately they did come in and do what needed to be done. But for a period of about 4 to 5 years, Flint, Michigan had a real big issue. And even though the EPA had some teeth to do something, it took them a long time to get around to it. The Environmental Protection Agency is there for a reason, and we want to make sure they're going to have our backs when it comes down to you or me or anybody else in the country for that reason. That wraps it up for section 3. Come back next time and we'll talk about ocean pollution.